What I'm going to try to do is to talk about transportation fuel quality. And I have a consulting business since I left GM in 2005 that's called Transportation Fuels Consulting. And I call myself an expert in vehicle emissions and transportation fuel quality and alternative fuels. Obviously, fuels and vehicles go together, and you have to have a good fuel quality if you want good performance and drivability and durability and all the other things. This is the outline. First, I'll tell you a little bit about me and who I am, where I come from. Why is fuel quality important? That's obvious. How is fuel quality affected by recent policy decisions? What effect does ethanol have on the quality of fuels and vehicle operation and materials, and some additional resources that you might find useful? I call myself an expert in emissions and fuel quality and alternative fuels. 35 years with GM. I was at Powertrain and ended up at Public Policy Center at Renaissance Center. I worked with the Coordinating Research Council, which I was on the board of directors. I was co-chair of the emissions committee. I've written a few technical policy papers on the areas of emissions and fuel quality. I was involved in various fuel quality initiatives. There's a document called the Worldwide Fuel Charter and the GM Well-to-Wheel study. I spent 6 years consulting for a variety of clients. Full disclosure, I'm doing some work for the ethanol industry now and have for a couple of years. But I've also worked for the U.S. Department of Energy, for the National Renewable Energy Lab, for the Department of Defense. I'm an expert witness. I worked for NYC Law, and I've taken various biofuel producers through the EPA process to be registered to sell their product. Worked on the California Reformulated Gasoline Predictive Model revisions, that California Low Carbon Fuel Standard, Mid-Level Ethanol Blends Research Group. Transportation fuel quality, it affects everything pretty much: performance, drivability, durability, emissions. Some of the drivers of quality are, over the past 40 years, are the Clean Air Act, largely driven by emissions. CAFE, corporate average fuel economy increases drive consistent fuel quality specifications. Energy policy, generally energy policy, in my words, if you boil it down, is focused at the reduction in petroleum fuel use and the reduction in greenhouse gas emissions. And just in general, the use of alternative fuels kind of for its own reason. People seem to like alternative fuels, and just kind of for their own reason. So what's happened over the last 40 years in terms of fuel quality improvements? There's a whole list of them. Obviously, lead is gone, and it's been replaced by aromatic hydrocarbons and oxygenates in some cases. The ones that I've got the little birdie asterisk afterwards are generally emissions driven things in my mind. Sulfur was reduced by 90%. We had 300 parts per million sulfur in the early 90s. We're now down to 30 parts per million. We had improved deposit control additives, greatly improved with fuel-injected engines, with a lot of other things. But it's worked to get uniform specifications in fuels, so that we've got a uniform fuel that we can pretty well rely upon, not just in one state, but in most of the states in the United States. Reduced vapor pressure. Most of the vapor pressure fuels in the summertime are no higher than 7 pounds, 7 or 8 psi. Improved refinery processes, drivability index, which is a combination of the distillation properties in gasoline. Reformulated gasoline, obviously the MTBE ban, and now we're kind of focused on renewable fuels and how do we get renewable properties in fuel. The renewable fuel standard, as I said, will drive 36 billion gallons of renewable fuel, corn-produced ethanol, derived ethanol, will increase to 15 billion gallons in 2015 and later. Put that in perspective, we use about 140, 150 billion gallons of gasoline a year in the United States. So 15 billion gallons is, what, 10% roughly. At any rate, we're supposed to make this up with cellulose-derived biofuels, which is kind of a dream. Will it ever happen? I'm not sure. There are a number of companies that I've taken through EPA certification and the registration process that are going to try to make cellulose-derived fuels. They have processes in place. They're very expensive now. one of the bigger questions is how do you integrate it into the existing refining and distribution infrastructure? That's it's a huge deal. Right? There's biodiesel and other things, advanced biofuels, but the main thing out of the Renewable Fuel Standard is that it was premised on two things: to reduce greenhouse gas emissions, but carbon, but also reduce petroleum fuel use. The California Low Carbon Fuel Standard is based entirely on carbon reduction. All they're interested in is greenhouse gas emissions. California Low Carbon Fuel Standard, it by contrast calls for a 10% reduction in carbon from the fuel content. The refiners are the regulated parties. They have to figure out how they're going to get 10% reduced carbon. That's a difficult thing to do. The Renewable Fuel Standard, which will get you to 36 billion gallons, would only get you to 6 or 7% of the Low Carbon Fuel Standard. So the California specification is will require much more use of renewable fuel. So keep in mind that that's not just California, but it's 13, 15 other states. Ethanol is currently blended, as we said, 70 to 80% of gasoline at 10% level, which is 3.5% oxygen, just for your information. EPA approved a waiver, which we already talked about, 15% for 2001 and later model year. Mid-level blends are coming as well, though, that the ethanol industry is going to try to market those. They'll be driven to some extent by the Renewable Fuel Standard, but that's for flexible fuel vehicles only. Essentially, all U.S. vehicles have been designed for E10 since the early 1980s, so there shouldn't be an issue. It isn't a difficult thing to design. The autos, the oils, and so forth have been testing all aspects of E15 and E20 for a couple of years now, and have identified any issues, and basically there aren't any showstoppers. Now we're going to get into the engineering stuff. These are the unique chemical and physical properties of ethanol that are different than gasoline. It increases vapor pressure when it's blended with gasoline. If you blend 10% ethanol, you're going to get a bump of 1 psi in vapor pressure. It forms azeotropes with some hydrocarbons. Again, you need to adjust the baseline gasoline properties in order to have something that won't vapor lock. There's a higher heat of vaporization, which is an important thing. It's actually a higher vapor pressure, but it doesn't vaporize as readily because you get more permeation through the elastomer components, water solubility. So it's just a matter of distribution facilities, terminals, and so forth have to have good housekeeping practices, they have to watch the water content. The energy content we already talked about, 76,000 BTUs a gallon for ethanol, 114,000 BTUs for gasoline. This is what it does to a distillation curve. But if you put ethanol on, it's a single property, and it's going to change the look of that distillation curve. Ethanol attributes. Now let's talk about some positive things. It's a good motor fuel. It's a renewable product. In other words, it isn't, we're not going to run out of it. We can produce as much of it as we want. It's domestically produced. We don't have to import it. It extends the transportation fuel supply. And this is a chart. ExxonMobil does they call an energy trends report, and they're saying that in the next up through year 2030, basically we're going to have a 40% increase in energy demand. We're going to need every source of transportation fuel that we can get, and we're going to need to develop some alternative sources as well just to meet global demand. We need a hedge against petroleum fuel supply and price shocks. Ethanol issues, plenty of those. Increased vapor pressure, we've been talking about that. Permeation in fuel system elastomers, tailpipe emissions effects of ethanol blends, it increases NOx emissions. A low relative energy content reduces vehicle range. Low pH fuel causes corrosive fuel pump wear. E20 and higher is definitely going to have to be sold on an energy equivalent basis. Vehicle content accommodations, this came from GM. Increased swell and softening of elastomers and polymers. That's what ethanol does. If you take an old rubber hose and soak it in ethanol, it's going to get soft. But if you use fluoroelastomers, it's fine. So with your old cars, if you upgrade the elastomers and polymers, you shouldn't have any trouble at all. Corrosion of metallic components. If you've got an old fuel tank with a metal fuel tank with a turn coating on it, it'll take the turn coat right off and send it right up through the fuel system. You don't causes electrochemical issues, fuel level sender, and in-tank fuel pumps. Kettering University did a study here recently, very, very timely. They released it October 2010. They were contracted by Hagerty's Insurance. And said, you know, look at old cars. So what they did was a component test of carburetors and fuel pumps. They did what they called a static test and a dynamic test, where they had a '69 Chevy Bel Air, and they got carburetors and fuel pumps, a combination of used and new parts, and they subjected them to what they called a dynamic test of, you know, it was a flow test essentially of these parts, and then they had a static test where they dripped. It was a drip test, and 2,000 to 3,000 hours, so it's a respectable test, I think. They published an SAE paper. They concluded no evidence to suggest that the use of pump grade E10 will lead to imminent operational failures. Additional resources, I got some additional resources for you if you're interested. There's my friend Bob Reynolds that wrote a couple of things here. Changes in Gasoline 4. It's written for the auto mechanic. It's a pretty good primer on gasoline properties and their effects, and it's, you know, he's a knowledgeable guy. It's on the Renewable Fuels Association website. It's ethanolrfa.org. And there's compatibility, reformulated and oxygenated gasoline with fuel system materials, downstream alternatives. Again, it's my friend Bob Reynolds who wrote that. And this last one here, Handbook for Handling, Storing, and Dispensing E85. That's something I wrote, but I wrote for DOE. You know, and I recommend it to you not because you're going to have any concern about E85, but because it goes through a lot of the stuff that I just talked about.
Thank you very much.